The Create Lab is dedicated to defining a new kind of relationship that a university research lab can have to communities around the world. And that new kind of relationship is based on one premise, the idea of the idea of empowerment through technology fluency. Now, technology fluency means turning the power relationship between technology and users upside down. Instead of having users be mere users of technology, we make users masters of technology so that they don't use technology but understand deeply how it works and guide its future deployment and its future evolution. On the other side of this equation, empowerment means that we work side by side with communities of practice from around the world. And what we do with each community is work with them ethnographically, participatory design, trying to understand what new innovation can disruptively change the way they can help make the world a better place. So those two together define us. I'd like to show you a few examples of that, and I'm going to start in the world of visualization, which Lenore just referred to. We invented GigaPan because of the need to create arbitrarily large images. It's a robot system that is able to take an ordinary camera and take pictures that have billions and billions of pixels. It's also a server system that can store those images and then serve them and, in fact, coordinate their presentation interactively to any website in the world. As a result, we work with National Geographic, Time Magazine, Sports Illustrated, and many others to create syndication. So we can syndicate these interactive images to any site. That picture from the World Trade Center is an example of a GigaPan. It was a quad fold in Time Magazine. But once you've done that, once you've been able to create massive imagery like that and understand on the server side how to capture really big data, you get interesting requests. Google and USGS came to us and said, what if we took every Landsat image ever taken in history and stitched them together to make the biggest video ever? So we did that, thanks to 30,000 Google processors and a whole lot of our server bandwidth. The result of that was Time Machine, which looks like this. And it's an interesting project because, in fact, what you're doing is you're able to visualize change across the world. You can see deforestation in the Rondônia region of South America, Brazil, and you can also see Lake Mead shrinking every year as Las Vegas grows. So it allows you to see the impact that we have on the world and the impact the world has on itself. That kind of visualization isn't merely in the world of pixels, though. You can do this with pixels, and you can spin out a company like GigaPan that's successful. We have hundreds of thousands of these images and now videos going online. But in fact, you can do the same thing with our architecture for data. So we had an interesting request. We had folks who were interested in understanding land use as we mine this country. Things like natural gas fracking have people thinking about the idea that our land is becoming tessellated with production, with pipelining, with pads. But they want to be able to visualize that data. That's not pixels, that's vectors, right? That's data on top of maps. But with a standard layer, you can only show a few hundred layer points at the same time. So using the same technique and the same data structures, we can show 50, 100, 200 million points with ease on a regular browser. What's powerful about that is you can take multidimensional data, any amount of data that you have, exascale data, show it, and then fly through it in time and space and try and make your point. In this case, the most exciting thing you can do, and you can Google this and watch the video and interact with it, is you can see well pads across America, and you can co-locate earthquakes. And it's absolutely fascinating to see what happens to earthquakes in America as people start mining the land in furious levels of density like that. It's quite scary. Now, we do this kind of work with gift funding from Google, Intel Corporation, and Microsoft. But the foundations come to us with a different question. How do you take our children and grow them up in a way that they will be able to invent things far better than this when they grow up? You don't do it by giving them an app and having them use screen time. The question is, what do you do with them? And we're trying to answer that question. The first place we start in answering that question is at the very young. We start with 4-year-olds and 5-year-olds. We give them literally wooden blocks that have discrete electronic components on them with a professionally developed curriculum that over the course of a year has them building with these. And they don't just build with these, they take apart Goodwill toys, electronic toys. And by the end of that, a 5-year-old can build a completely new electronic toy from existing toys. That program worked so well in one kindergarten in Pittsburgh, Allegheny that we spread it to every kindergarten. Then it worked so well in every kindergarten that it's now taught in every class through 4th grade. The company that we spun out from that actually builds these from sustainable timber and went live 2 weeks ago. So you can actually buy these kits now, and I'll have one here for you to look at. So that's called Children's Innovation Project, and it's an example of yet another spin-off. By the time your kids get to middle school, the problem we have is a huge gender gap problem. A lot of kids aren't interested in technology during middle school because we take technology and we isolate it. So instead of isolating it, we made an arts and crafts kit. You take arts and crafts material, build any kind of robot you wish. It can be pretty. It can look like a rabbit. And yet, the Hummingbird controller, which we also spun out, allows you to control that, choreograph it, and program it. But we don't put this in a technology class. This goes in your humanities classes. It goes in every poetry class, English class, anatomy class, and history class. What happens is you break the barriers down between technology and humanity. Those are artificial barriers. They don't need to be there. And so the children learn that you can use technology to create narrative. And as a result, their power relationship to that changes. Hummingbird, by the way, is doing a massive Kickstarter campaign right now, and it's close to success. It's been selling for about 3 years. They've sold something like 20,000 of these across the nation now. And its sales are going up every year. So it's another company that we've spun out. I have a board here on that too. Now there's a question of scaling. As you bring out products like this, making a company is one thing, but how do you really logistically enable anybody around the world to benefit from it? This is a picture from last week. That is Mayor Rahm Emanuel in Chicago announcing that you can now check out Finch robots if you want to learn how to code from the Chicago Public Library system. This is the Finch. We spun that out 3 years ago. So that's another company. What's exciting is the idea that this is robust enough that you can put it in a library and have people check it out. But going through libraries and imagining scaling that way, that only reaches places where you have strong library infrastructure, and that's a few cities and a few countries. How do you go more broadly? This is a map of everywhere that the Create Lab has programming today, and you'll see that it's much more broad than a few libraries. The way we do this is, the secret sauce is 3 fundamental things, and they all are related to a number you see there, 650 organizations. What we do is we partner. It's all about organizational networking. We partner with schools of education. They create training for pre-service and in-service teachers so that a pre-service teacher can go into the classroom armed with this. We partner with organizations that actually warehouse equipment for educational school districts. We also partner with social organizations, activist organizations, and social engagement organizations around the country and around the world. It's those relationships that make it possible for 30 of us, 30 designers and engineers, to have reach internationally. Of course, the other thing you have to do is you have to commercialize it, because you have to be able to meet the demand you're going to have if the thing succeeds. And so it's kind of a neat story of how a university can take commercialization and massive organizational partnership and put them together to have impact globally. Now, one question that I have to answer that I always enjoy answering is, what are you doing next? We've been moving toward environmental sensing. And the reason for that is it's a hot topic, it's a very good area for STEM learning, and it has a massive market. We just spun out a company that makes a water quality meter that you drop in the toilet tank of your toilet, the cold water reservoir tank. Every time you flush your toilet, it gives you a water quality reading. This is very useful for rural areas where there's fracking going on nearby. So that's commercialized and out the door. It's a company named Spearco. But what I want to talk about is a new company that we're just forming now. It's around air quality. You all know the problem on the air quality side. 1/4 of every emergency room visit today in America is asthma. We already know that particulate matter affects asthma, but we also have learned recently that particulate matter actually builds up in your body cumulatively and causes arrhythmia and cardiovascular disease. So basically, a whole lot of the ills that we have to do with the particulates in the air, the little 2-micron particles in the air. And we know that China has a massive problem this way. We have 70 million households in the US with this problem. In China, it's growing 40% every 5 years, and that's just asthma, not even talking about cardiovascular disease. And they're aware of it. They wear masks. They compare filter paper on Baidu, trying to figure out if their filter works or not, and they don't know if it works or not. So what you need is a device that can take the invisible, air quality, particulate matter, and make it visible cheap. If you can do that, can you empower people to actually make their homes more healthy? And the answer is yes, you can. We made one. It's this device. It measures particulate matter in the air, and it just costs $20, $30 bill of materials. So what we're doing with this device is creating an internet infrastructure that guides you to understand what's wrong with your air in your house and what actions you can take to make the air better, together with the visualization of the air quality you have in your home. And this is something that we're actually incorporating right now, and we're going to look for Series A funding this summer. I have one story to tell you about that that's fun, and then I'm done. Utah, Salt Lake City. A school there borrowed 20 of these from us a couple of months ago during the pilot testing. And they asked an interesting question. They had their students go and count how many parents idle their cars during pickup. So they counted it up, and then they put the air quality meters in their school classrooms and measured the air quality for a couple of weeks. Then they did an education campaign. They taught the kids how to talk about particulate matter and go talk to their parents about idling. Then they went back 2 weeks later and actually had the kids count how many cars were idling. And guess what? The numbers dropped massively. And they measured the air quality again. They didn't just get a decrease in particulate matter in the classrooms. They got a decrease with a p less than 0.0001. That means there's a 99.999% statistical correlation between the action the kids took and the air quality improving in their classrooms. That's exciting because that's empowerment run amok. You're learning about air quality, you're measuring it and becoming a scientist, then you're becoming an activist. You're talking to your parents, making change and measuring that the change that you made has direct impact on your health and the health of your classmates. So our ambition in terms of air quality and all our other projects is, can we do this in every school around the world? Can we do this in every residential home in the world? If we can do that, we can make the world a better place and have a successful company at the same time. Thank you.